Hi, this is section 4.4, logarithmic functions. So the definition of a logarithm is as follows. The base has to be greater than 0, and the base cannot equal 1. If that's true, then you have log base b of x is equal to y is equivalent to b to the y equals x. So the way I like to do this is I like to cross out the word log, and then I swap these two numbers, and that's how I get b to the y, because the y goes to the left side, equals the x goes to the right side. So that's the way I like to do this. So let's do that for this first problem. Cross out the word log and swap these two values or numbers, and you get base 5 to the second power equals 25. And that's all they want us to do. They just want us to write this in exponential form. So this is called logarithmic form, log form. And on the right, you have exponential form. So there's two equivalent forms. Usually when you have it in log form, you usually want to convert it to exponential form. So same thing goes here. You would cross out the word log, swap these two numbers. So you have base 6 to the 1/6 exponent equals x. And that's all they want us to do. They don't want us to solve. For the next set of problems, we're doing the opposite. We're writing each of these equations into logarithmic form. So it's basically the same thing, but you have to write the word log. The base is 4, as you can see. That's your little subscript. And then you switch the exponent, and the 64 gets switched. So you have 64 comes to the left side, and 3 goes to the right side. So this is the equivalent form that we're looking for. Let's do the same thing over here. Write the word log. Swap these two values or numbers, and you get base 5. There's your base. And then the 1 over 125 goes to the left. I'm going to use parentheses. And on the right side, you got the -3. And that is our final answer. All right, now they want us to find the value of each logarithmic expression. So since we're trying to evaluate these, you want to set it equal to x so that we can convert using our definition. So if you convert, you're going to have base 10 to the exponent of x is equal to 1 over 10. All right, so our goal is to write these both in base 10 so that we can actually solve for the exponent. So another way to write 1 over 10 is to write that as 10 to the -1 exponent, because the -1 tells you to take the reciprocal. So 10 to the -1 is 1/10. And now since we have the bases the same, now we can set the exponents equal to each other, and that is our final answer. Same thing over here, set it equal to x, cross out the word log, swap base 9 to the exponent of x is equal to 3. Our goal is to make the bases the same, which we can. We can call 9 3 to the second power, because that's the same thing as 9. On the right side, we have 3 to the 1. So now we multiply the exponents. 2 times x is 2x. And now the 1-to-1 property allows us to say that 2x equals 1. Set the exponents equal to each other. And now divide by 2. X equals 1/2 is our final answer. Same thing goes for these problems. This time they already have the equation set up for us. So now we just have to solve. So we apply the same definition. Base is 5, exponent is x, equals to the 1 over 25 power. And remember, we can write these bases, we can make the bases the same if we use base 5 to the -2, because -2 will turn that into a 1 over 25. And now x has to equal -2. For the next one, same thing. Base 13 to the x is equal to 1. Well, the only exponent that will work is when the exponent is 0, because any base to the 0 power is 1. So whenever you have any log of any base of 1, your answer should always be 0. For the next one, we're going to get base x to the third power equals 8. Take the cube root of both sides. X is equal to the cube root of 8, which is 2. X to the second equals 25. Let's take the square root of both sides. X is equal to plus or minus 5. However, remember the base cannot be negative. The base has to be positive, so therefore it's just the positive 5, not the negative 5. All right, for these are a little bit different looking, but you would solve them the same way. You can set it equal to x, and then you can use a definition to rewrite these as base 5 to the x is equal to 5 to the third, which implies that x must equal 3. Notice there's a shortcut here. If you go back to the original problem, whenever the log base is equal to the base of the x of the power, whenever these bases are the same, the answer is always going to be the exponent. So in this case, the answer is just 3 because the bases are the same. Same thing with this one. The shortcut applies. The base is 2. The base of the log is 2. Because they're the same, these are going to cancel each other out, and you're just going to get 7. Over here, well, we can apply the one-to-one property for logarithms. That is, if log of A is equal to log of B, then A must equal B. So whenever you have a log equal to a log with the same bases, that means you can set the arguments equal to each other. This is called the argument. So you can set the arguments equal to each other. So I'm just going to say implies. This arrow means implies. So now we solve for x. So add x to both sides. Subtract 4 to both sides. You get 2x equals 3. Divide by 2. X equals 3 halves. Whoops, that's a negative 3. Yeah, that's a negative 3. So that's a negative 3 halves. All right. The one thing that you cannot have is you cannot take the log of a negative number. If you try taking the log of a negative number, you're going to get undefined. And that's because the domain of the log function is only positive values. We'll learn this later, but I'll give you a sneak peek. This is what the graph of any log function will look like. It's going to go like this. And this is a vertical asymptote. So as you can see, the values are only positive. There's no negative value, so you can't take the log of a negative number. However, if you plug this into here, you still get a positive number. And if you plug this in here, you're still going to get a positive number. Because 1 minus negative 3 halves is equal to 2.5. That's positive. All right. For this one, notice that you don't have a log on the right side. You only have a log on the left side. So you can't use the one-to-one property. But what you can use is a definition. You can rewrite this using the definition as an exponential equation. Base 3 to the exponent of 2 is equal to x minus 4. 3 squared is 9. Add 4, and you get your final answer. X is equal to 13. Same thing goes for this one. You would apply the definition to rewrite this as an exponential equation. Base 9 to the negative 3 halves is equal to x. Well, if you recall, we have this formula that we can use. 1 over a to the mn. And then remember, m over n means that you're taking the nth root and then you're raising it to the m power. So the n is your root or the index, and the m is the exponent on the outside. So this would become x equals 1 over 9 to the positive 3 halves, which is the same thing as square root of 9 to the third power. The square root of 9 is 3 to the third, which is 1 over 27. So our final answer is 1 over 27. The final question for this section says if interest is compounded continuously, so continuously is our key word. That means we're using this formula from the previous section at a rate of 4%, so that's 0.04. Approximate the number of years it will take an initial deposit, so that's your P. Initial deposit means P, 6,000. To grow to, that's the final amount, 25,000. All right, so we have our A, 25,000. That's the amount we want it to grow to. We have our P, the initial deposit. We have our interest rate, 0.4, and we're looking for how long that's going to take. We're looking for T because the question is asking approximate the number of years it will take. So we're looking for T. So in order to solve this equation, you have to divide both sides by 6,000 first. Notice all these zeros cancel, so you really get 25 over 6 is equal to e to the 0.04t. And if you recall, the way we get rid of an e is by taking the natural log of both sides. Take the ln of both sides. That allows us to move the exponent to the front. So we have ln of 25 over 6 equals 0.04t ln of e. But remember, ln of e is just equal to 1. So in other words, that just basically goes away. And now to solve for t, we divide by 0.04, and that will do it. So the time will be ln of 25 divided by 6, close parentheses, divided by 0.04. I'm getting 35.67, so I'm going to round that to about 35.7 years. So that's how long it would take for an investment to go from 6,000 to 25,000 if you're compounding interest continuously. And that concludes this section.